So now let's look at a couple of examples here connecting the Riemann integral to the definite integral. All right, so what we're really just trying to do here is we're trying to see how to translate the limit of a Riemann sum into an integral. Okay, so this is the idea. If we were doing the limit as this norm of the partition goes to 0 of the sum k equals 1 to n 2ck cubed delta xk, where delta is a partition of the interval -1 to 0, what would this really be talking about? Well, it's talking about a certain function being integrated over an interval. So it would have this structure: integral of some function. So I'm going to make this for a second here, some function, and then we're going to use the variable x dx from, and these boxes I'm eventually going to get rid of, but I'm just trying to get the format of what's happening. All right, so basically we have the integral of some function in here from some place to some place with respect to x. So now I just need to figure out what goes in here. So one part is pretty easy. This is saying we go from a to b. So -1 to 0. Okay, so now I'm going to get rid of some of that extra stuff. And then what is the function? Well, that's right in here, because this is what would be f of ck. So if f of ck is 2ck cubed, then that means, f of x would just be 2x cubed. So all we have is 2x cubed, and there's our definite integral. The integral from -1 to 0 of 2x cubed dx. All right, just a translation problem. Okay, let's try another one. The limit as the norm of the partition goes to 0, the sum I equals 1 to n, 2 over 1 minus ci delta xi, where delta is a partition of 2, 4. Okay, again, it's the integral of something, and we'll use the variable x. And we don't have to, but it's nice to use. So it's definitely the integral from 2 to 4. And the function, if this is f of ci, if this is f of ci, then basically f of x would just be ci replaced by x. So 2 over 1 minus x dx. And that would be our definite integral. Again, it's giving the limits of the integration, 2 to 4, and then it's telling us what function we're integrating according to what variable. So all of those are important parts of the definite integral. Now the next question is going to be, how do we evaluate this thing? All right, so that's a good question, and rather than going back to those limits of sums from before, we want to work towards a different way. But we have to make our way there. So the first thing we're going to do is see if there's some things that we can say about definite integrals in general. Okay, so here's one thing. So let's look at the first. So we're going to get either values or modifications of these integrals by some properties. So the integral from a to a of f of x dx, let's think area. If we go from a to a, then we haven't gone anywhere. So there's no width to this region, there's no area. That would have to be 0. So any integral any definite integral that stays at one place, goes from one number to the same number, or same one place to the same place, has to integrate to be 0. All right. So what about going from B to A? Well, we can't give the value of that. We can say that in terms of going from A to B, f of x dx. So these are not the same, they're negative. So the idea is that if we have some area that we're integrating from A to B, the convention is that we're going A to B, that going from left to right would be positive if it's above the x-axis, and if we go the other way, it's negative. All right, so it's the negative of the value we'd get from A to B. So this sort of signed interpretation of the area is going to be useful as we go forward. Okay, so that brings us to another interesting property. If we want to go and do the integral from A to B of f of x dx, the fact is that we don't have to go straight from A to B. We could go the integral from A to C of f of x dx plus the integral from C to B of f of x dx. So we could go to any other point. Now this makes a lot of sense if we were talking about the case where we're going A, B, and C is in the middle here, because you'd be saying the whole integral is just the sum of those two areas. That makes sense. The interesting thing is that we don't actually need C to fall between A and B. So C could be out here. So how do we end up getting this area? Well, realize that if we go from A to C, we would get this red area. And then if we then went from C to B, we would then really be subtracting off this portion right here. And in the end, we would end up with just this area in here. So that idea of subtracting when we go back here actually allowed us to take away this region here. So that's an interesting thing, is that we can go, if we want to go from A to B, we can go from A to any other point and then that point to B, and it doesn't have to even be inside. Okay, so what about the integral A to B of k f of x dx? When we had indefinite integrals, we saw we could factor out the k, and that we can do here as well. So if you have a constant, in other words, something that isn't involved in the variable of integration, then it can come out. All right. Now, how about if we have the integral of f of x plus or minus g of x, the definite integral? Well, when we had indefinite integrals, we could break this up. We can still do that in the definite integral case. Plus or minus, whatever you have. All right, let's see this in an example. So let's say we're given, so we don't know why, but we're given that integrating from 0 to 5 of some f of x dx gives you 10. Integrating from 5 to 7 of some f of x, same f of x, gives you 3. Could we get the integral from 0 to 7? Well, yeah, because the integral from 0 to 7 would be the integral 0 to 5 f of x dx plus the integral from 5 to 7 of f of x dx, which would be 10 as given plus 3 as given, so it would be 13. Good. How about the integral from 5 to 0 of f of x dx? Well, we only know the integral from 0 to 5, but we know 5 to 0 would be negative 0 to 5. So it would be negative of the 10. How about the integral from 5 to 5? Oh, same point. 0. How about the integral from 0 to 5, 3 f of x dx? Well, we know that the 3 can come out. So it would equal 3 times the integral 0 to 5 f of x dx. 3 times we know that to be 10, or in other words, 30. So we were able to do all these calculations without knowing how to do the integral, but based on knowing what the integral means, what the definite integral in this case means.